Most of the 15 questions from tomorrow will come from those 5 days we did in class, of the most common topics asked on the Regents exam. And there will just be some that maybe we talked about once, or maybe not at all. All right, no formula sheets. I'll just give you the actual one that'll be on there in case you need that. And that'll be it. All right. So yesterday I assigned some part 1 questions. So first thing, I'll go over anything in June 2022 for part 1 that we want to go over before I start parts 2, 3, and 4 with you today. Anything in part 1s we want to go over. Go in. If we're going to do well, we got to do well in the multiple choice. That's our first hurdle to get over. Forget about the next parts 2 through 4. We got to do well in the multiple choice. So nothing at all. Part 1's going. Okay. Next up here. So here we go. Stay in that exam. Can you just circle these 5 problems? Those are the ones I want you to work on when I'm done talking today. And also make a note, we're done with this exam today. We go quick here. So tomorrow I'm going to start working on January 2020 with you. So those are the 5 problems you're going to work on when we're done with our class set. Tomorrow in class, I need you to have the January 2021 printed out. Okay, everyone good? Ready to go? And then make sure you have January 2020 in class tomorrow for it. Print it out. All right, first one today. We're going to go to the part 2, 3s, and 4s today. So show your own work now. These all have to be done in pen, remember, unless you're doing a construction or doing a graphing on an actual piece of graph paper. All right, this has to be all done. I'm not asking it to be done in pen now. I'm just reminding you. Got to be done in pen. Seat numbers are all up on Classroom when you have time. All right, make sure you write it on the inside cover of the 5-day review packet. So let's look at 26 right now. You guys see 4 arcs that are in this ratio. We know by now at this point in the year, anytime I see numbers in a ratio, as long as it's not partitions, I put X's with them. So everyone go ahead and label your arcs with 2X, 3X, 5X, and 5X. And now I'm looking for angle B. Even before I get to angle B and we talk about what type of angle it is and how do I find it, how can I find X? So I can actually find how many degrees all these are. They add up to what? 360. So let everyone go find X right now and plug it back in so we can find the arc lengths, or arc measures, excuse me. So all those arcs add up to 360. Find all the arcs now. 10, 15. By the way, anybody in this class leave a calculator in the back like days ago and never got it back? Because that's the case, and I have it now. So everyone good at the arc measures. 120, 120, 48, 72. All right, let's get to angle B now. Anybody remember what I call angle B? That's what type of angle in the circle. I have to know what type it is to make sure I remember what rule I need to use. That's an inscribed angle. All right, angle B is an inscribed angle. Anybody remember how to find an inscribed angle? Half its arc. All right, half its arc. So I'm going to take half. Now everybody look at the arc that angle B is drawn to. If you want, I always like to highlight it so I know Everyone see the arc? It's 72 and 48. So I'm going to take half of that full arc, ADC. So I'm taking half of arc ADC. So I'm going to take half of, what's that, 0, carry the 1, 120? Yeah? So angle B, 60 degrees. All right, 2-point question. All right, not much work involved. Remember that. Anything in part 2, I always think of part 2 questions like multiple choice without the multiple choice. All right, it shouldn't be a lot of work and you're grinding away. If you are, maybe you just don't see it. Okay, questions? All right, moving on here. Next one, looking at 28 now. 28. Second time we've gone through this. So one parallelogram is mapped onto the other by a reflection. Use properties of rigid motion to explain why those two parallelograms are congruent. What did I do to one of them? What's the transformation going on? That's what I thought too. Good job. It's a reflection, right? All right, so here we go. You guys know the wording. Properties of rigid motions. Reflections are, you guys taking it from here? Reflections are rigid motions, which I'm just going to let you guys keep rolling. Preserve, angle measure, and distance or side length if you want to put side length. Anybody want me to use a special word?
Thus.
You got it. Thus, parallelogram EFGH is congruent to parallelogram IJKH. There we go. So just want to make sure we know the rules. It's not that funny. Questions? Yep, walk by my room, make it awkward in a second as we all stare at you. Okay. Don't bother me. Don't ruin my teaching. We're good. All right. One thing we have not done, we might have, probably will have to in a couple weeks. The old statements, reasons. Yes, let's go. God, I love these. It's been since Unit 10. Probably since before April break, we've done these. Yes. Few things here. First thing is, and it happened, I don't know, it's happened. You have to write in all the givens. Don't pull one of these, a little here and a big G for given, like I've seen in the past. Don't point an arrow from the givens to number 1. Actually write out the givens. Because legitimately, all joking aside, they did take a point off a couple of years ago if you don't write your givens in. Again, I don't care what you do when you study and write in your own work, but game day, please write in all the givens. All right, prove PT congruent to RU. Only way we're doing that is if what gets done first. What's got to be done first before I get to PT and RU? What's got to get done first? We know this. What's got to be proven congruent first? The triangles. Yeah, this is CPCTC. So can you help me get the triangles congruent? Then I'll get PT, and RU. And remember, we're still in part 2, correct? Or this is part 3? This is part 2, right? Shouldn't be that bad of a proof. Should be a 13-stepper. All right, or is it, this is part 3?
Yeah.
All right, jeez. Yeah, part 3. So it's only 4 points. It's not the big dog, so it shouldn't still be a 13-stepper here. All right, QT perpendicular to PS. So I got right angles, and SU perpendicular to QR, and it's a parallelogram in the middle. All right, help me out. Anything you want to start writing? Contribute anything. Spence.
You have to say the right.
Thank you, Spence. Got to say they're right angles because I'm about to say they're congruent. Angle, what can I call that angle? Oh, no, I got to call it 3 letters. QTP and angle, let's see if I, QTP, SUR are right angles. Perpendicular lines form right angles. And then yes, very next step, now you say they're congruent. Put a little, I'll put a little A next to that. That tells me I have an angle now. All right, good job. I got a pair of angles, everyone. Now where? Anything else you know is true? Remember, the whole thing's a parallelogram. Know your property. Spence, you want to keep rocking? Let's go.
US is congruent to QT.
US and QT. Remember that the inside one's not the parallelogram, Spence. It's PQRS. So you're right, but change it now. Apply it to PQRS. Which sides would be congruent? Which sides would be congruent now? I don't want QT and SU. I want what instead?
RQ and SQ.
RQ and okay, true. Are those in the triangles though?
Look, you can subtract it to make it
Subtract them from what?
I don't know.
Come on, keep going here. We're getting there.
RS and QP.
All right, there we go. RS and QP. I like those. So everyone see where we're going? QP congruent to RS. Opposite sides are congruent. QP and RS. All right, everyone. Here you go. Reminder of the reason. Parallelogram, because that's what was given, implies now what property did Spence just use? Opposite sides congruent. There's a side. All right, I need one more piece from you. Anybody have anything else in those 2 triangles that are going to be congruent? What's up, Anna?
Angle URS and TPQ.
Perfect. Angle R is congruent to angle P. Know your properties of a parallelogram. Opposite angles are congruent. R and P. Angle R congruent to angle P. Parallelogram implies opposite sides, opposite angles, sorry, congruent. Good job, everyone. Good work, team. Good work. All right, now I could say the triangles. Now you guys have to decide, is it angle, side, angle, or is it angle, angle, side? Look at the side, see if it's in between or not. So now let's say the triangles are congruent. So triangle, what am I working with here? QPT is congruent to triangle. If I go QPT, I got to go SRU. What do you got here, guys? Is that side in between or not? Is the side in between? Absolutely not. So I got to go angle, angle, side. And then let's finish this up. CP, CTC, PT, and RU. This is not bad for if this is the type of proof. Again, I don't know any advanced knowledge of the questions. Could be a similar triangle proof. Could be a coordinate proof. Could be a CP, CTC proof. All right, all set. Good times, I know. All right, last one I'm going to do with you is the big dog, part 4. Number 35, 6-pointer. We did a coordinate one yesterday in class, and it looks like last year's one was a coordinate one too. Does that mean this year's going to be coordinate? No, it does not. Don't assume. But if it is, we'll be prepared. All right, if you want to go ahead and graph triangle ABC, go right ahead. And actually, last year, the kids got it easy. This was an easy one for a part 4. Prove it's isosceles. So I need to show 2 sides congruent. What formula am I going to need for this then? Distance formula, yep. And make a judgment call here. I think we're pretty confident it's going to be AB and AC. And remember, the distances should be equal. They're telling you to prove it's isosceles. So it is isosceles. You just got to prove it. All right. So here we go. Step 1. Make sure we label our steps. I don't get to grade your exam. Don't be a hot mess for whoever does. All right. Make it neat. Make it organized. So let's find the distance of AB. Have we put this in our calendar there? Distance formula? Probably some of you have already filled it in. X2 minus, if we haven't yet, here we go. X2 minus X1 squared plus Y2 minus Y1 squared. Might need it tomorrow. All right, here we go. Let's find the distances. You do it. I'm not going to do it with you. I'll do my version up here. Square root of 50. Looking all right. And also, if it doesn't say simplest radical form, don't be heroes, please. Don't be a hero, because if you try to be a hero and simplify that and it's incorrect, we got to take off, even though you had square root of 50. So don't be a hero unless it says simplest radical form. So we're everyone square root of 50. All right, now here we go. Keep writing our steps. Step 2, we could say it's isosceles because AB is congruent to AC, or 2 sides are congruent. So triangle ABC is isosceles because
Here's what I found from mathgoodies.com. A triangle is isosceles if and only if it has 2 congruent, equal sides.
there you go. Perfect. ABC is isosceles because 2 sides are congruent. By the way, if that happens on game day, somebody has a smartwatch and it starts talking, just watch me fly down an aisle and just leave my feet and just spear whatever kid that is. And you'll never see that kid again. He probably won't be able to eat solid food for 3 weeks either. So make sure you tell your friends that are taking the geometry exam. Leave your smartwatches at home. Any issues with this first part? Spence, I'm ready. You try it out too, because you know I'll put you in a headlock in a second.
Do you have to prove that BC is not congruent to the other ones?
No, here's why. Because even if it is, it'll be equilateral, and an equilateral triangle is also isosceles, so it doesn't matter. Yeah, good call though. Good call. If you did, would we take off? No, it should be all right. We're all good on isosceles. All right, let's move it now. So let's take triangle ABC, translation of 5 units right and 5 units down. And notice how it says I need to state the coordinates. So make sure we write down here what is A prime, B prime, and C prime. So we're translating it at 5 right, 5 down. So do your thing, everybody. Three -1, -2, -6, and 2 -8. I do that right? How does that look? Can I get a little confirmation? Looks all right. Before I move on, all right, last part. And this could be a lot more complicated, this last part. Prove quadrilateral A. Let's connect them now. A prime, C prime, C is a rhombus. How would you prove it's a rhombus? What would you? Because I'm just asking because there's multiple ways we can make this into a rhombus. I have it the easiest way, I would think, for us, but easiest way to show it's a rhombus: show all sides congruent. Yeah, show all sides congruent. Makes it a rhombus. You already found one side, so you don't need to do that over. Everyone, right? We found side AC already. So all you would need to do is, all right, transfer that. All right, we already found AC was the square root of 50. I don't need to do that over. But now here we go. Now we got to do A prime. And the other two sides as well. A lot of distance here. Make sure you can find these. Just don't plop a radical 50 down because you know it's going to be radical 50. And then once you have all four distances to be the square root of 50, now last step, hey, A, B, C, D, oh, not A, B, C, D, sorry. A prime, C prime is a rhombus because all sides are equal. This could have been a lot tougher. It's as easy as this for us. Whew. Thank our lucky stars. Show all the work, nice and neat, right? Last thing, hey, take a look up here, please. Last thing. This can be done in pencil. That graph can be done in pencil. All this work we showed around it has to be done in pen, though. All right, so that's what I mean by graphs in pencil. That graph can be done in pencil, but all the surrounding work that we've been doing in 3 parts has to be done in pen. All right? Okay, work time. Here we go. Let's roll work time. Get the answer keys out. Call me over if you're stuck on anything. Anything, call me over.